Today, you will learn one of those topics that is easy to understand but hard to master. Today, you will learn what is recursion, but also how recursion works in memory. So stay tuned if you want to master this confusing topic. Hello coders, welcome to my channel. I am David, your guide to mastering programming. Let's code a Fibonacci sequence. If you don't know what Fibonacci sequence is, it's a sequence where first two elements are 0 and 1, and every next element is calculated as the addition of the previous two. So for example, the next element would be 1, the next element would be 2 because I need to add 1 and 1, the next element would be 3, and the next element would be 5. If you found this video helpful, make sure to like the video and hit that subscribe button. It really helps me out. Thanks for your support. I'll create a function, call it fib, and here I will pass n, which will represent the position of the element that I want. For example, 0th position, first position, second position. Now I want some base cases. If someone passes 0, I want just to return 0. I don't need to calculate anything. Return 0. Also, if someone passes 1, I can also just return 1. Why? Because this is a base case. Now I will have previous 1, which will be the first previous element. It will be 1, and previous 2, which will be the second previous element, which is in this case 0 from the beginning. These two elements here. Now while n is greater than 1, repeat this loop. Current element will be equal to previous 2 plus previous 1. And now the previous 2 will be equal to previous 1 because I will shift these elements here, as you can see. 0 and 1, when I add them, it will be 1. And now the second previous will be here and the previous will be here. And previous 1 will be equal to current. And I need to reduce the n, otherwise this would be infinite loop, and return previous 1. So now here, if I call, for example, fifth element, which is 5 here, I expect to see 5. As you can see, 5. If I write, for example, I don't know, 6, I expect to see 3 plus 5, which is 8, to see 8. It works. This solution is called iterative solution since we iterate through these elements here using a loop, while a loop. This code works the way we wanted, but with recursion we can simplify the code by using the formula for Fibonacci sequence. As I have told you, the formula is the previous element plus the next previous element. You create the recursion the same way as any other function. As you can see here, def, fib, but the only difference is recursion has to have this return. And I will show you why in a moment. Next, I can simply code this by using the formula. For example, return fib, what is the formula? N minus 1 plus fib n minus 2. Now when I run this code, as you can see, it still prints 8. I can also write here 1. It also prints 1. I can here write 13, and it also works. It prints 233. So the important thing with recursion is that it has to have these two. I mean, it doesn't have to have two, but it has to have some base like this. These are called base cases with return to tell Python that you don't want to have recursive calls anymore. So when you reduce this n until 0 or 1, this will return 1 and this will return 0, and that way you won't have any recursive calls. The advantages of recursion is that it can help you easily code some abstract problems by dividing it into smaller subproblems. It's easier to understand what this code does than the previous one at the first glance, but the drawback is that every recursive call is very expensive. It takes a lot of time and a lot of space. That's why Python limited the number of recursive calls. I'll create some, e- some easier function to demonstrate you that. For example, def printer and if n equals 0, return. Here print n, and he'll call printer n minus 1. As you guess, this code will print the element backwards. For example, if I print 10, it will print them 10, 9, 8, and so on until it reaches 0. Then it will return and the recursive calls will stop. So if I call here printer and write 10, as I have told you, it prints 10, 9, 8, 7, 6, and 5. But what if I write here 1,000, 100, for example, first? As you can see, it still works. But what if I write 1,000? As you can see, it says recursion error, maximum recursion depth exceeded. Python limited the number of recursive calls to 1,000, but it takes some more, 3 calls from you because it needs them. It needs that memory and CPU power to run recursion correctly. So there's a special module in Python that's called import sys, which is short for system, that can tell you what is the limit. For example, here print sys dot get recursion limit. As you can see, it will print you 1,000 here. As you can see, it prints 1,000. Also, you can set your own limit. For example, sys dot get no set recursion limit, and you can here write the number you want. For example, 3,000. Now, when I print here 2,000, it works. There is no error. But keep in mind, if you write here too big of a number, your program may crash because of Stack Overflow. I will show you in a moment what Stack Overflow is. But first, I want to ask you something. What will happen if I put this print from here to here? If you know what will be printed, write down in the comments below. Printer, and here I'll write simply 5. As you can see, now it's printed 1, 2, 3, 4, and 5. Not in the reverse order like before, 5, 4, 3, 2, and 1. To understand why recursion works like this, I need to show you how recursion is called in memory. Memory has two specific memory types. One is stack memory and other is heap memory. I won't talk about heap memory in this video, but I'll have to explain how stack memory works. Stack memory works like this. For example, if you call a Fibonacci function, the call will be here. Fib, for example, what? Fib 5. Then, if you call the Fibonacci again, the stack memory will put that call on top of this one. It will draw here a line and here write now fib and write 4. Then fib and here 3. Then fib 2. Then fib 1. After this fib 1, it reaches 0, which returns and tells Python that you don't want any recursive calls anymore. Now this stack memory is starting to empty, but stacked empties from the bottom, I mean from top to the bottom. It's a LIFO memory, which means last in, first out. So Python gets first this one, so 1 is printed. Then it empties this fib2, then 2 is printed, then empties this fib3, then 3 is printed, then empties this fib4, and 4 is printed, then empties this fib5, then 5 is printed. Which means Python first runs these calls, as you can see, they never reach to this point, and after return, this part of the code is replaced with emptiness. So now Python calls them in this order as I have shown you, fib1, fib2, fib3, fib4, and fib5, and all those values are printed in that order. I hope you have understand how this works. Now I want to show you how recursion works with instance, class, and static methods. First, I will create, for example, class number. Let's copy this code because we will need it. Class number. First will be instance. Here print. As you know, instance method has to have one instance parameter. But now the difference is that you have to call the function using the self dot and then printer. Now, for example, if I create n to be equal to number, now I can call n.printer. Oops, I didn't pass anything. I'll pass 3. As you can see, it works. But if I create a class method, at the rate sign, then write the class method decorator, and here create this function. First parameter is the class itself. Now, if I want to call the printer, I need to use this CLS here, the class instance. I mean, not the class instance, but the class itself. Now I can here number dot printer and here pass 3. As you can see, 1 to 3 is printed. But if I want static method, for example, I need to write static method decorator. But now I need to call this printer using the class name itself. For example, my class is named number, so I need to call this by using number.printer. And now here, if I print number.printer and pass 3, I will remove this so it doesn't confuse the Python. Now when I run this code, as you can see, 1, 2, 3 is printed. So the conclusion is you can use recursion with instance, class, and static methods, but with instance method, first parameter has to be instance itself, and the function has to be called using that instance parameter dot and then the function name. The same applies with class method, but now the first parameter is class itself, so you need to call the function using that class parameter itself with dot and then the printer. I mean the function name, but with static method, you don't have any instance or class methods, but you have to call this recursive function using the name of your class. Like in my case, number, so number dot then print. I hope you found this video helpful. Like and subscribe for more coding content. See you in my next video. Until then, keep coding.